Last but definitely not least, Rudy Tanzi, the Massachusetts General Hospital. Rudy is literally a rock star of science. He played again on Aerosmith's 2012 Music from Another Dimensional. Easily the best Hammond organ player ever, according to Joe Perry. We got all kind of ways, Rudy, so watch yourself. Recent Hub Week headliner with Deepak Chopra, consults on brain health for the Patriots. Dr. Rudy Tanzi is the Director of Genetics and Aging Research Unit and Vice Chair of Neurology at Massachusetts General Hospital. He is also a Joseph P. and Rose F. Kennedy Professor of Neurology at Harvard Medical School. Rudy co-discovered several Alzheimer's disease genes, which is a big deal, in the Alzheimer's Genome Project. He is actually developing therapies for treating Alzheimer's based on the knowledge gained from the genetics and lifestyle. Rudy published over 500 peer-reviewed papers and has received the Metropolitan Life Foundation Award, Potamkin Prize, the Smithsonian American Ingenuity Award, and was on a 2015 Time 100 Most Influential People in the World list. He also co-authored the New York Times bestseller Superbrain and Super Genes with Dr. Deepak Chopra. I got to say, pal, you got a lot of good things you've done, but you know what's really cool is that you're like a really normal guy, too, which is really amazing. So without any further ado, see if this works.
Oh, no.
You're up, pal.
You have Joe Perry play. Oh, wow. Okay, Ralph. Uh-oh. I think that's me playing blues harp. I'll never forgive him for this. All right, well, yeah. All right. That was definitely a surprise, Kevin. Oh, my word. Well, thanks so much for having me here. And it's really a pleasure and a privilege to speak on behalf of the panel to give you an update on Alzheimer's over the next 20 minutes. I believe there's the time. Any one of us could have given this talk, maybe except Bob. No, Bob could give the talk too. So I'm going to talk about Alzheimer's with a theme of, how are we going to stop this disease before it starts, right? I just want to say from the beginning, it's kind of crazy that we don't diagnose Alzheimer's disease until symptoms. And let's not take that for granted. Imagine if we did that with cancer. Imagine if we waited till you had symptoms of cancer or symptoms of heart disease, or if you wait till you have an MI or congestive heart failure to say, oh yeah, you need to manage your cholesterol. And that's what we're doing with Alzheimer's, right? We're telling people we're going to treat your amyloid 10 years after it peaked and plateaued, and they already have symptoms, and we say, now we're going to treat you. So this is what has to stop. And I think this gets to the core of precision-powered medicine and health, where you actually have to detect Alzheimer's before it starts. The pathology begins before symptoms. So, of course, Alzheimer's is the most common form of dementia in the elderly. We say there are 5 million patients in the US, but if you take everyone who has the pathology and a pre-symptomatic on their way, kind of like with cancer, having a neoplasia or a small tumor that may or may not cause cancer, the number of patients based on pathology, not symptoms, goes up to probably 25 million in this country, meaning it's probably the most prevalent disease once you think about people who are carrying the pathology and have a high probability of going on. And now, given that 30 to 40% of people over 85 have AD, this is the fastest growing population in the US and even in the world. Current lifespan is 80. I mean, this is just an epidemic that can completely wipe out Medicare and Medicaid. And it's no surprise that the number of cases will at least triple by 2050. So we need to do a lot better. And I think this conference is right at the heart of what we need to do, which is early prediction, early detection, early intervention. Risk factors include age, family history. I'm not supposed to use gender anymore. I was told the right word to use is sex, but I don't want people to think that sex is a risk factor for Alzheimer's disease. So I refuse to put sex on there, even though we're not supposed to use gender. I apologize. But Kevin mentioned that 2/3 of patients are women. And you know what? Yes, they do live longer, but even when you adjust for how long they live, you look at women from 65 on, if you look at men versus women from 65 on, it's almost double the prevalence and risk for AD as you go through your lifetime for women versus men. I think it's 1 in 6 at 65 can expect it in their lifetime, and it's only 1 in 11 for men at 65 expecting this disease in their lifetime. So things are going on, maybe postmenopausal energy metabolism, inflammation's more rampant, for example, in women with MS. So there's lots of possible reasons. Stroke has recently been shown to cause tangles, like head injury. We heard about CTE and head bangs leading to tangles. And even loneliness is a risk factor, emotional trauma. And our current drugs, Aricept, Namenda, et cetera, treat the symptoms modestly and temporarily. They're a Band-Aid. We need to do much, much better. Now, the early genes that we and others found back in the 80s and 90s, going back to when I was a student at Harvard, and I've been at Harvard and Mass General my whole career, all those genes like amyloid precursor protein, APP, presenilin 1, presenilin 2, well over almost about 300 mutations now, and most of them, all of them lead us back to amyloid beta protein, the A beta, as we call it for short, that leads to the plaques. And the majority of those mutations increase the ratio of the long A beta 42 to A beta 40. A lot of people misspeak and they say, oh, with early onset familial Alzheimer's, where you have these fully penetrant autosomal dominant genes, you produce more A beta. Well, one mutation does that, the Swedish mutation in APP. Most of them affect the ratio of long to short A beta. That's the target for these patients. And ApoE also affects A beta clearance from the brain, and ApoE is not fully penetrant, but 12-fold increased risk with 2 E4s, 3.7 with 1 E4, and now people are going to 23andMe, and they get an E4, right? So I'm getting multiple emails per day. Think about it. 20% of people who do 23andMe are finding out they carry an E4. 2% are finding out they're homozygotes. And then they go to the web and read statements like 93% of E4 homozygotes will have Alzheimer's by 70 years old, which is a fake statement. I mean, yeah, it increases risk, but I mean, we actually are thinking at Mass General we have to start a protocol to address the concerns and anxiety of people who are finding out they're E4, how to further assess risk and mitigate risk. But this is the age we're in. People are finding out information through direct consumer testing, and then they're finding misinformation on the web and they're freaking out. And stress is also a risk factor for Alzheimer's, so that's not good. So these are all the genes, and Suda found many of these, the different genes. And what I did was I put them roughly under the pathologies they most correspond to. The 3 pathologies, A beta plaques, the tangles, neuroinflammation, which is actually the brain's innate immune system turning against itself. In fact, at the end of the day, you can almost say that Alzheimer's is an auto-innate immune disease because it's neuroinflammation in the end that causes the most damage. But I can't possibly go through all these genes, but I do think that the double head arrows matter, that amyloid can lead to tangles, it can lead to inflammation, inflammation can lead back to amyloid and tangles, so you do get a vicious cycle going. It was George Glenner who first proposed the amyloid hypothesis back in 1983. And George was a pretty amazing guy, chain-smoked Marlboros, had a gruff voice. I saved all of the voice memos he ever left me as a student telling me to go after the amyloid gene. He said, Rudy, go after the gene. I'm telling you, that's where it's at. Don't listen to those people who say it's not amyloid. And I saved all these. And I loved the title of his paper where he first said, everything starts with amyloid, the commonest form of amyloidosis. So they didn't have spell check back then. I'm pretty sure commonest is not a word, but if anybody could use it, it was George Glenner. So George was the first guy. He was an amyloidologist, and he said Alzheimer's is an amyloidosis. And this is what happens. That middle thing is APP. There's beta secretase clipping it at the cell surface. Now presenilin and gamma secretase comes in, and now the little A beta protein is going to be released. See you later. And now he's, with all these other A beta, under the right conditions, if you have too much long A beta or you have the right acidic conditions or too much concentration, you start to form oligomers and fibrils that can lodge in between synapses and actually get in the way of neurotransmission. Here you see it again. So some drugs are attacking that enzyme, beta secretase, and they're in trials. We are using gamma secretase modulators that affect the blob that just hit to try to turn the long A beta back to short A beta. But this is the battlefield for so many drugs right now. And as I'll tell you later, they all failed. And we'll have to think about why and what we're going to do next. The other thing, these are the tangles. The tangles are forming inside of neurons as opposed to outside. You're in a microtubule now, in an axon. There it is, the cytoskeleton. It's fraying because tau is being hyperphosphorylated, falling off. You see the little orange blob below. That's the beginning of a tangle. And so this is now leading to neuronal cell death, and you have these tangles that can actually be spit out by neurons and spread. It's a spreading pathology that can keep going. So one of the big questions was, do plaques lead to tangles? This was the big question for the last 2 decades. And if you look in mice, the answer is no. So if you put these early onset familial genes in mice and you have them make lots of amyloid, yes, the mice eventually get some neuroinflammation and have issues with cognition, but they don't get tangles. And so this led to lots of debate about whether amyloid really causes the disease. It should cause the tangles because that's what's really killing the neurons at the end of the day. So some of us argued, and I'll show you the slide, that we're not mice. So I tried to use this slide in one of these TED Talks, and they said, that's way too scary, you can't. I love this guy, right? They didn't let me use it, so I said, okay, how about this one? They said, nope, that's copyrighted by Disney. We'll have to pay money to Disney. So I finally had to go with this pathetic thing, the little mouse man. But it makes the point that that's not who we are. We're not mice. And so how can we do better? And then there's been a big movement now in using stem cells, human stem cells, to create neuroprogenitor cells, create neurons. And originally, these were grown in liquid. And surprise, surprise, you didn't mimic Alzheimer's. The brain's not made of liquid. Brain's made of gel, so do the whole thing in gel and 3D cultures. And sure enough, now when you start to make A beta, it will form plaques in the gel. And you also see neural networks, like the one on the left. These neurons make connections, they fire. And on the right side, you also are seeing a plaque. So that's in a dish. And the postdoc who did this, who's now assistant professor, Du-Young Kim, came running in and said, we have a plaque in the dish, and that little orange blob. And like a proper PI, I remained unimpressed and said, how about the tangles? But literally, he came back 2 weeks later, and sure enough, we had tangles. Those appeared helical filaments that were forming after 8 weeks. The plaques form after 6 weeks in the dish. These are human Ren cell stem cells turned into neurons. So these were the first bona fide tangles made in a dish. But importantly, and I won't go into the details here, if you blocked the amyloid from forming in the dish with beta secretase inhibitors or gamma secretase inhibitors, you block the tangles. So it said tangles follow plaques. If you block the plaques, you don't get the tangles. We sent this off to Nature, and the editor said, well, can you stop the tangles even if there's still amyloid? So now, Nature's running my lab. Right, this editor came in and run my lab meetings. But we did that, and what we found, I'll just show you the summary of it, is GSK3 beta. So plaques do lead to tangles if you use human neurons. And if you turn off GSK3 beta, you can have all the plaque you want in the dish. You won't get tangles. So that's at least one kinase that's involved in that phosphorylation step of tau that leads to tangles. So I think this helped add some proof of concept for the amyloid hypothesis once we get out of the mice. And now we know that the mice make the wrong form of tau. The tau isoforms in mice are just not prone to making tangles like they are in humans, and that was the big breakthrough. So here we have the idea that plaques can lead to both neuroinflammation. We've known that for a long time, but they can also lead to tangles, that neuroinflammation can lead to more tangle formation. So plaques, so we can look at Alzheimer's as an amyloid-driven tauopathy, an amyloid-driven tauopathy also leading to neuroinflammation. But relevant to the last session, and this is for Bob, you can also get it this way. Okay, you don't want to be that guy. Too many bangs to the head can also lead to neuroinflammation and tangles directly without the need for amyloid. And we can talk about this, but it seems like in CTE, you go directly to tangles and inflammation. You don't need amyloid plaques to slowly accumulate to get there, although later on you will see some plaques in the later cases of CTE. So this says hit amyloid, yeah, but like I mentioned, all the trials failed, all of them. Every trial trying to either turn off amyloid production or clear it out, clear the drain, all of them failed, and why is that? And I think in some cases they just weren't very good drugs. They didn't get into the brain. In some cases, they didn't really make sure they recruited Alzheimer's patients into the trials. There are other dementias, frontotemporal lobar dementia, vascular dementia. Now they do, in many cases, check for amyloid first in the brain. So many reasons, but this is probably the main reason, is that plaques are occurring, and this is a slide many of us show, decade or two before dementia. So you see the graph on where it says amyloid. The amyloid's already peaked. It's already gone up and plateaued by the time you have dementia. The tangles come a little later. Neuroinflammation I have there at the end, but really that can be at the beginning as well. But the problem was, and I have repeated head injury or strokes can also get you directly to tangles and inflammation or amyloid. But what we were doing is treating people way out there with dementia with amyloid. So, I mean, if you look at inflammation as a forest fire, and think about the tangles as brush fires that got you there, and think about amyloid case as the match, right? Or CTE, head bangs are the match, and Alzheimer's, amyloid is the match. Tangles form and spread like brush fires. Neuroinflammation is the forest fire. What we were trying to do is put out a forest fire by blowing out the match. And that's, so we have to hit amyloid much earlier. So this is the slide I like to use. We've been diagnosing it too late. So here's this guy having a heart attack, this poor guy, and the doctor says, it's okay, we just need to lower your cholesterol. You needed to do that 10 years ago, 10, 15, 20 years ago. Now with Alzheimer's, same thing with amyloid. So the big problem is we don't diagnose Alzheimer's until symptoms. This is unlike heart disease, cancer, diabetes. And we target beta amyloid too late. We need to really know by imaging right now, soon, hopefully there'll be a blood test. Kevin, right? You're going to get a blood test? Yes, thank you. So once we have a blood test, you won't have to have expensive imaging, and we'll know who's at risk early on. Let's say, when we have actionable drugs that stop amyloid safely, then you will stop bringing your amyloid down as soon as you find out. Some of these drugs might be beta secretase inhibitors. We and others, including Pfizer, are working on gamma secretase modulators that don't block the enzyme, but just turn the long forms into the short forms of A-beta. There are various antibodies being used, Lilly, Biogen, and Roche. But I think we're going to have a good battery of therapies that would be safe over the next few years, and where we can start bringing amyloid down once you know it's too high. For this to happen, the FDA has to play along. Right now, the FDA wants you to improve cognition by hitting amyloid, which is probably not going to happen. I mean, maybe we'll get lucky with Biogen and aducanumab doing the very mild stage patients, but this is it's a really high bar to hit. I'm hoping the FDA will look at the genetics data, look at all of the data, look at the 3D Alzheimer's in a dish data and say, you know what, if you have a safe little white pill or maybe for big hits an antibody that brings amyloid down safely, and somebody has high amyloid in their brain or a blood test shows that, let them take the drug. Don't make us show that you hit cognition because we might never get there. So that's going to take a leap of faith by the FDA to get there. But I think that's our best chance for hitting this disease early by allowing us to hit amyloid a decade or so before symptoms. We're also screening for other drugs. Cure Alzheimer's Fund is a major foundation in town that funds this work. What we've done is we've done a screen where you'll see Tangles up there in the plate. So we said, among all the FDA-approved drugs and a bunch of other natural products and other drugs, can we find ones that stop Tangles, at least by 90% phospho-tau and tangle reduction? Now, if we did this in mice, it would be 8,000 mice, 24 months, and millions of dollars. In the dish, it's 10 times, maybe 100 times cheaper. It's a matter of doing this whole screen in 3 months versus 2 years. So we've done a screen, and we came up with 38 different drugs, including approved drugs, that stop Tangles by at least 90% in the dish. And what I can tell you is that some of these drugs stop amyloid and thus stop the Tangles, right, like the beta secretase inhibitors. But some of them stop the Tangles, like the Nature editor wanted us to do, stop the Tangles even though there's still amyloid. So we've now gone through the approved drugs, and we're going to be doing trials at Mass General with some of these approved drugs you would never have guessed could work, especially the ones that are hitting Tangles even though there's still amyloid. Because if you stop the Tangles, you stop most of the cell death and the inflammation. So we're concentrating on those. And for recruitment, this is a paper that came out from Rebecca Petoskey at Mass General just recently. We usually use CDR sum of the box scores to come up with power calculations for trials. And in this particular simulation, you would need 1,200 patients to get a result if you just went by cognition, neuropsych score with CDR sum of the boxes. But if instead you looked at tau imaging and staging of tau and Tangles in the brain by imaging and recruited your patients that way by Brack stage, actually using pathology to recruit, then you only need 230 patients. So I think recruitment is going to start being much more based on, as we're seeing, imaging of amyloid, also imaging of tangles, and we can also bring in genetics because there are genes that are more relevant to tangles versus plaques or relevant more to neuroinflammation, as shown here. So we can start stratifying by pathology with imaging or maybe with blood tests once Kevin gets off the stage and stops wasting his time. Sorry, Kevin.
Never wasted my time with you, Rudy.
No, I know that's true. That's true. We had some good times. So basically, imaging, biomarkers, so we can recruit with genetics and evidence of what's going on, not just based on neuropsych score, so that we can use fewer patients and get leaner and meaner and more nimble with trials, have more power. For inflammation, these are the two targets, CD33, which we first described in 2008 as a risk factor, TREM2, which was found in 2012. These determine microglial activation of inflammation. This is the new Alzheimer's in a dish we have now, where you're seeing in that radial thing, the brain is in the middle, the mini brain organoid. Those red guys are microglial cells that are marching in from the side through microfluidic channels, and we can ask whether they're neuroinflammatory, killing neurons, or whether they're clearing amyloid. And we can put drugs in that reservoir on the outside and ask what happens to microglia, which are the first cells that drive inflammation. The microglial cells then turn on astrocytes and astrogliosis. So this is another system we're using. And then finally we get to this, basically hitting amyloid, hitting tangles, hitting inflammation. I included on the side there viral and brain pathogens because I don't have time to talk about it today, but recently we showed that amyloid's not just junk, that amyloid beta protein appears to be an antimicrobial peptide protecting the brain against infection. And we know that this is just showing down at the bottom, a herpes virus being completely covered by A beta and forming a plaque within 2 hours once you put it into either a dish. In a mouse, that takes about overnight. So plaques overnight just in response to herpes virus. And this is the list of the growing list of infections that you see in the AD brain, low-grade infections. And I don't have time to get into it, but amyloid looks like it's being formed as part of the innate immune system to trap these pathogens like a classic antimicrobial peptide, and the plaque becomes a classic nanonet that antimicrobial peptides use to protect tissue, in this case, amyloid protecting the brain. So in the end, to stop Alzheimer's, we need a cocktail, might need a cocktail, to curb plaques, tangles, and neuroinflammation. We can consider this secondary prevention. If hitting the infections, if the infections are, I said, amyloid's the match, tangles the brush fire, inflammation the forest fire, maybe microbes light the match, right? That you have amyloid forming as a way to stop microbes. So that would be primary prevention if we can hit the microbes that do this. In the end, though, like I said, early prediction through looking at family history and genetic risk, that will then determine your diligence and vigilance level for early detection, imaging, biomarkers, maybe microbial assays, and then most important, early intervention. Stop pathology, maybe even infections before you have symptoms. In the meantime, all we can do is use lifestyle. So I like to use this slide to end. We need to move more. I should be playing basketball right now with Aaron, who's here. We need to learn more, sleep more. We'll talk about this. Meditate more, eat better, and choose your ancestors wisely. So I'll stop there. Thank you.